Okay, so let's start with the very first section, which is representation of vectors. Now, where is a vector? Where is a vector quantity? If you guys can recall, vector quantities, these are quantities that has what? That have both, they have both what? Magnitude. They have both magnitude and direction, okay? Yes, they have both magnitude and direction. The opposite of vector is scalar quantity. Quantity that have only magnitude, okay? Now, vector quantities, these are quantities that have both magnitude and what? And direction. You all know the meaning of direction. Direction means path. Yes. Now what about magnitude? Magnitude means amount. Yeah, magnitude can mean amount. It can also means numerical value. Numerical value. And also it can also means numbers. They are the same thing. It can also means what? Numbers. These two are the same thing, okay? Yeah. So that is what magnitude is. Magnitude just means amount or numerical value or numbers. Now let me break it down for you guys. Now, for example, they say a car was moving with a velocity of 25 meter per second due east. Due east. A car was moving with a velocity of 25 meter per second due east. Now, if you look at this illustration, you find out that this due east signify what? Signify the direction. What about the magnitude? It is what? It is this number 25. 25 is what? The magnitude. Remember, I told you guys, magnitude means what? Magnitude means numbers. That is just it. Yes. A force of 30 Newton, a force of 100 Newton, a force of this, a force of that. The 100 there is what? Is the magnitude. The 50 there is what? Is the magnitude. Okay, now let's continue. Representation of vector. How are vector quantity represented? Vector quantities are represented by an arrow. By what? By an arrow. Please take note of all this. The vector quantity is represented by what? By an arrow. The head of the arrow, the head of the arrow represents the direction of the vector. The head of the arrow represents the direction of the vector, while the length of the tail, this is the tail, this is the tail of the arrow, this is the head of the arrow. Okay, so the head of the arrow represents what? The direction, whereas the tail, or you can say the length of the tail from here to here, the length of the tail represents what? The magnitude. Okay, the length of the tail represents the magnitude of the vector. Now let me break it down. For example, they said, okay, let me say for example, um, okay, 5, then 10. Okay, between these two vectors, which one is bigger? It is this. Why? Because of the magnitude. The magnitude, even though they are going in the same direction, but they are not the same. Because why? Because they have different magnitude. If you look at the magnitude of this vector, you find out that it is 10. It is bigger than this second one. This second one, the magnitude of this second one is what? Is 5. What now? If you look at these two, like what is the major difference? It is, if you look at it, the length of the tail. Yes, the length of the tail is what differentiate them. This is what differentiate them. The length of this one tail is is longer than this other one. I recall I told you guys that the length of the tail, or you can simply say the tail represents what? The magnitude. Yes, the tail represents the magnitude of the vector. If you look at this vector has large magnitude. You can tell from the length of the tail or from the number itself. While this other one has a small magnitude, you can also tell from the length of the tail or what? Or the number. So that is just it. A vector is represented by an arrow. Yes. A vector represented by an arrow. The head of the arrow represents the direction of the vector. But if, for example, I do something like this, it shows that the vector is going north or upward. If I do it like this, it shows that the vector is going south or downward. Do it like this, it's going east. Do it the other opposite direction, it's going what? West. Okay. Now the other last thing I will also tell you guys. Please take note. Yeah. Remember, I told you guys that the head of the vector represents the direction. Also take note that angles angles can also represent the direction of a vector. For example, they say a load of 50 kg was moved by a force of 30 Newton, for example, was moved by force of 30 Newton, which is inclined at an angle of 30 to the horizontal. Inclined at an angle of 30 to the horizontal. Now, you look, if you can tell that this angle is what tells you the direction of the force or direction of the vector. I don't know if you understand. Let's say, for example, 30 degree above. This is 30 degree above the horizontal. This is 30 degree. You see, 30 degree. It shows that the vector is going where not north east. Yes, angles also signifies and also represents direction of vector. And angle can also tells you the direction of vector quantity. What if they say if a vector is moving, okay, let's say a force of 30 Newton is used to lift a load. Okay, that's what if they say a force okay, what if they say a force inclined at an angle of 90 degree? Now, what will be the direction of that vector? 90 degree. Now, let's forget about this part now. 90 degree, what will be the direction? What will be the direction of the vector? To be upward. To be upward. We reference with the horizontal. This is what? This is 90. This is 90 degree. To be what? Upward. What if they say the vector is moving at 180 degree? 180 degrees this side, I'll be from here to this side, I'll be, so the vector will be moving what? In this direction. What if they say 270 degree to be moving what? Downward. So that's to tell you that angles, apart from the head telling you the direction of the vector, angle also tells you the direction of what? Of the vector. It does that too. Angle and the head represent the direction of what? The vector. Okay. Now move to the next aspect.